Do an optimization example. This says find two positive numbers whose sum is 120 and whose product of one number times the square of the other number is a maximum. So for optimization problems, you want to ask yourself two questions. The first question is, what am I optimizing? So what do we want? I want a product of one number times the square of the other number to be a maximum. So let's make that an equation. I'm going to say P for product equals, and let's just make our two numbers x and y. So I'm going to say x times the square of this other number, so x times y squared. We want this product to be a maximum. So that's what I'm optimizing. Second question is, I want to know what is my constraint. And our constraint is that the sum of the two numbers is 120. So I'm going to say x plus y equals 120. Now, since I'm optimizing my product, I eventually want to take the derivative of p because I want to know where my maximum is. So I need to find that critical value. But before we do that, I want p to be an equation of one variable on the right-hand side. So it doesn't matter. I can replace either the x with y's or the y's with x's, but our derivative is going to be easier if we replace the x. So over on my constraint equation, I'm going to solve for x. So I'm going to say x equals 120 minus y. And I'm going to replace x with 120 minus y. Distribute the y squared to make our derivative easier. And now we have our product as an equation of one variable on the right-hand side. Now that we have that, I'm going to take my derivative with respect to y on both sides of the equation. And we get, on the right side, dp dy equals 240y minus 3y squared. Now, we know that the max product, or well, we want the critical value. We're hoping it's a maximum, but we're hoping the max product is where dp dy equals 0. So I'm going to replace dp dy with 0. And let's solve for y. Factor out a GCF. I have a GCF of 3y. I'm left with 80 minus y. Okay, so I get y equals 0 and 80 minus y equals 0, or y equals 80. So I have two critical values for y, or I should say for p. But keep in mind that the problem says we want two positive numbers. 0 isn't a positive number, so we're not going to use 0. So we're hoping it's a max at 80 and not a minimum. So let's double check on a number line to be sure. So at 80, I know that dp dy is 0. And let's check around 80 because I want to know where am I increasing and decreasing. So I want to be greater than 0, so I'm going to do this. So let's pick 10. Let's test 10. I'm going to plug 10 into dp dy. So we get 240 times 10 minus 3 times 10 squared, which is 100. So that's clearly going to be positive. 2400 minus 300. Okay, so p of y is increasing between 0 and 80. Pick something larger than 80. I might pick 100. Okay, let's plug in 100. Numbers are getting a little bit big. Maybe I'll plug in after we've factored this time. That seems like that might be easier. So I'm going to have 3 times 100, so 300, times 80 minus 100, which is negative 20. That's going to be negative. So we have shown we are decreasing, p of y is decreasing after 80, and that means that at 80, P has a max, not a minimum. So what did we just find out? So we know that at y equals 80, P of y, the product, is a maximum. Let's make sure we're answering the question. So they want us to find both positive numbers. So I found one of them, but I need to find the other one. I know that x, I already solved for y, so we need x. I know that x is 120 minus y. So let's figure out our other number. So x is 120 minus 80, which is 40. So my two numbers that satisfy this problem are going to be 40 and 80. And that is our answer.